Now I'd like to, from scratch, go over the proof of the fundamental theorem of calculus. Very important. You'll see in a lot of math you'll have these fundamental theorems, the fundamental theorem of arithmetic, the fundamental theorem of algebra, the fundamental theorem of calculus, which we're going to do now. So this is the first part, and I'm going to try to show, really what I'm trying to show is that some capital function, I call it area function, the derivative of the area function is equal to the original function. In other words, that a of x is the antiderivative of f of x. And this really shows the connection between differential, that's derivatives, and integral calculus. Okay, so let's start here first. First, we're going to let a of x equal the area function. In other words, it'd be like here under the red. This is the area under the curve, total area under the curve. And this green one over here is the area under this distance between x. It's x plus delta x would give me this new position here. So that would be the area all the way back from here all the way back, including the green and the red. So that would be all the area all the way back from green and red. So let's see what happens here. So now let's take a look at what we can do to show this. So first of all, we have a function y with respect to t. Okay, and there's right here is a particular x, little x value. And that would lead us up to this f of x, which is a height. See, that's a height. So if we scroll up a little bit, so the green area, what would you say the green area is? Well, the green area is this area all the way back from here, all the way back, minus this area in the red, which is this one back. And that's right here, do you see it? That's the area all the way back minus the area in the red. And another way to think of that, that's what's left. If you subtract that, right, you have what area in the green area. So if you take this area and subtract the red area from it, you're left with the area under the green curve here. This area, okay? But another way of saying that is taking delta x, right? Delta x is this guy right here, see it? And then multiply it times f of x. Because f of x is the height, so you have something like the height times the width. So I have two ways of saying the same thing. If you take the area from x plus delta x all the way back minus, and this should be right here, this should be minus a sub x. That would be the area from the red all the back. Okay, what did I do? Well, I'm saying it's also equal to f of x d of x, right? So this should be right here, should be d of x, yeah. Okay, now, so this area, which is all of the area minus the area under the red, would be equal to this area, which is really the green area. So if I divide both sides by, and by the way, I'm going to call this, let me get rid of this so that this is actually, it'll be a delta x. And over here, I'll get rid of this too, just to be consistent. Okay. I'll put delta x. Okay, so I have two ways of saying the same thing. So now I'm going to divide both sides here, as you can see, by delta x, right? So now I have f of x by itself over here. And then I have the area, the total area, minus the area in the red. It gives me the area of the green divided by a delta x. Now if I take the limit, so this is a limit as delta x goes to 0 of a minus the area from all the way back, all of the area minus the area in the red divided by delta, well, that would be, I'll take the limit of both sides. And this is as that goes to 0 too. So if you notice that f of x doesn't have a delta x, so it's like a constant, right? So when you take a limit of a constant, That ends up just being f of x. And on the other one, the definition of a limit, we're going to call this definition here. I'll get rid of this, and we'll call it the derivative of the area function, a sub x. So it's showing that the derivative of the area function is equal to the original function, or f of x. So in short, we're saying that a of x, a prime of x, the derivative of the area function, is equal to the function. So what we're saying is that a sub x is the antiderivative of f of x. And that's part one. Part two I put here is, it's really not rigorous. I'm just saying that we can see that if we want to know what the area is between A and B is, we'll take the area from A of B all the way back, see it? And subtract this area all the way back. So you can see why plugging our upper and lower limits gives us this area right here that we seek in right here. That's the area right there. By subtracting the area all the way back, see, this goes all the way back, minus the area from here all the way back. So that's not a rigorous proof, but it gives you a reason why you're subtracting the top antiderivative evaluated, the area function evaluated at B minus the area function divided by A. And that's that. Thank you.